Hi everyone, welcome. My name is David Habusha and I'm the VP of Product with a startup company called WhiteSource. What we're going to discuss today is basically the open source adoption and the challenges associated with it, why you should shift left your open source security and why is it different than handling proprietary code security, how we did a shift left product together with Microsoft, and then we discuss the lessons learned and have some time for questions and answers. So the trend today is that 60 to 80% of any software is using open source components. That means that if you have a software product that has hundreds of thousands of lines, let's say 100,000 lines of code, 60 to 80,000 of lines would be developed by other companies or other individuals that you don't have a lot of control on. Even most successful companies such as Facebook or Google use open source heavily. They also release open source components to the community such as Go or Angular or React and many others. But with the great power of open source also comes great responsibilities. Open source is a different animal. It's not your proprietary code. You really need to understand this. To be able to manage open source properly, you first need to understand what you have, what open source components are being used, and what are they dependent on, what other open source components are being called by these components. You need to carefully examine your open source security. You also need to maintain compliance and make sure you use open source licenses that comply with your organization's policies. And it's really hard to actually control the quality of open source components because they weren't written by you and the community tested them and not your QA team. Let's dive into license compliance. So when open source began, there were a few license types. Most of them were copyleft, meaning that you had to release your code as open source together with the open source components. But what we see right now in the industry is that people release open source components using permissive license types, most commonly MIT, that comprises now 25% of new open source components released to the market. And with MIT, which is a permissive license, you don't have to release your code as an open source component together with the open source component. And that's not the case if you use a copyleft license type like GPL. Open source security is a different animal than proprietary code security. When you test your code for security vulnerabilities, you usually run tools that either dynamically or statically analyze your code and finds vulnerabilities based on rules and heuristics. There's many tools in the market from big companies such as IBM, HP, Computer Associates, Checkmarks, and others. But you can't do that for your open source components because vulnerabilities in open source are being found by the community. They're available to everyone, and you need to continuously monitor your code for vulnerabilities. Let's dive into why open source vulnerabilities are different from proprietary code vulnerabilities. First of all, you need to understand that open source vulnerabilities may be found years after the component was actually released to the market. You can see the Heartbleed example that some hackers found a vulnerability 7 years after it was released to the market. And if you had OpenSSL code running within your systems, you needed to fix it, you needed to update it, and you need to continuously monitor to see if there's additional components that you're using that are vulnerable as well. There's no public information for vulnerabilities in your code. There's a lot of public information on vulnerabilities in open source code for good and bad. First of all, it's available for everyone, so new hackers can use that to hack into your system, but also it leaves room for the community to release fixes for these open source vulnerabilities. The remediation for proprietary code vulnerability means that you need to change your code or replace it internally. Usually the remediation for open source vulnerability is found in the community, and you just have to search and find the new version or the fix and apply it to your system. You don't have to fix it yourself. And this is a discussion I had this morning with a person that visited our booth. The major difference between proprietary code and open source code is that you cannot scan your system once. Even if you have a system that doesn't change and you scan it once and the dynamic and static analysis tools discovered some issues that you fixed, you're done basically. But with open source, you use the component in a certain version, and hackers keep on trying to find additional vulnerabilities in these components. So you have to continuously monitor and know what you're using and understand if there's new vulnerabilities published for the open source components you're using all the time. But open source has some disadvantages as well. First of all, not all the projects are maintained properly and follow rules. So some projects that are vulnerable, you don't always find fixes for, and the authors may not support the project anymore, so that might be a problem. As we said, the vulnerability information is available to everyone, including hackers, and we see that once a vulnerability has been published, most organizations take between 6 to 8 weeks to actually fix the vulnerability and patch, and other hackers can use this window to actually penetrate into these organizations' systems. There's also a matter of quality where basically an open source project is written by the community and anyone can add or change open source code. That means that there might be some questions about the quality of the components if developers that are not really good touch the component, and you might find issues with open source components that you can't really control. I mean, you can fix it and contribute back to the community, but that's an overhead. The good news is that whenever a vulnerability is found in open source, the statistics says that 87% of all the vulnerabilities are published together with a fix. So once the vulnerability has been published, you already have a fix in place and you can just apply it on your systems. Let's talk a little bit about the anatomy of how an open source vulnerability is being reported and handled by the community. So first, security researcher, usually these are white hat hackers that want to contribute and don't want to actually harm any systems. They found vulnerabilities in open source components, reminding you that they have access to the code, so they know very well how to penetrate into the code. They report that to the author of that open source component. The author of the open source component contacts an organization called MITRE, M-I-T-R-E, that maintains a database of vulnerabilities. Each vulnerability is assigned with a CVE number. This is an identifier of the vulnerability. At this point, the vulnerability is in a reserved state. That means that it only has a number, but there's no description of the vulnerability itself, so nobody can use it and exploit in this time. Usually there's a grace period of 90 days, allowing the author to fix this vulnerability. Hopefully the fix is being deployed within these 90 days, and then CVE actually opens and publishes the defect, the vulnerability, together with the fix. Usually that would be a new version released of that open source component that you need to apply in your system. If within these 90 days the author hasn't completed the fix, usually they would contact commercial companies that are known for contributing to the open source community to actually handle and release the fix to the community. The most known company that contributes is Google. So most people who can't handle the fix in time, they approach Google, which has a research team that releases these fixes to the community. And when it has been released, there's a database, one of many, that is called the NVD, the National Vulnerability Database, that has a detailed analysis of the vulnerability, together with the fix, and a CVSS number. CVSS number is a number that basically demonstrates how vulnerable the code is, both in terms of exploitability and in terms of severity. What is the business impact of the fix, and how easy it is to fix the issue itself. But it's not that simple. It's actually very complicated because the NVD is one database. There's many other security advisories and databases. Some of them are public based on the programming language you're using. Some of them are vertical. So there's a vulnerability database for financials, for insurance, and so on. And you need to be able to monitor all of these databases. But many of the bugs, actually, if you look statistically, are listed on the bug trackers of the companies themselves, usually in Jira, but it could be in any other bug tracker. So they're not even published to the public in a known manner. Even if the Jira is open to the public, you still have to go and manually search for that fix. There's also no way of actually searching these databases for vulnerabilities by open source component. So you search for vulnerabilities, but you can't get the list of all the vulnerabilities that affect the component that you're using, and it's really hard to follow dozens of databases. These are the top open source vulnerabilities, out of which Equifax is the most recent and known, and it was the largest hack in the history. And let me give you some facts about what happened in Equifax. Don't forget that we said that all the vulnerabilities are not just visible to you, they're visible to hackers, and they actually use it. We know that in the Equifax breach, people are actually using this hack and penetrate into additional systems. So Equifax, what happened? Equifax is using an open source component called Apache Struts, which you may know. It's the most commonly used open source from the Apache project, probably. To date, it has more than 60 known vulnerabilities. On March 7 this year, there was a new vulnerability discovered in Apache Struts. It was reported, not in reserved state, but actually published with a CVSS score of 10, which is the highest score, meaning that it's easy to replicate the vulnerability, and it also has a large business impact because it can steal a lot of proprietary information using the exploit. There's even YouTube videos that you can see that demonstrate how to use this vulnerability and hack into companies that use Apache Struts. 3 days later, on March 10th, the patch was released and published on the CVE. So basically any organization that used Apache Struts could have been safe by applying the fix. And researchers reported on mass exploitations in commercial companies, not just Equifax. The attack on Equifax actually happened somewhere between June and July, so they had more than 2 months to actually patch their system. And the numbers that were public are that more than 140 million people were affected. Their personal information was stolen. That's more than half of the US population, so that's pretty big. And this label is breached as the largest and worst corporate data breach in the history I'm sure there's going to be more coming exploiting open source. It took Equifax 1 more month to actually report the breach to the public. They probably had their own internal processes. By the way, the CEO resigned, their stock plummeted, and there's a whole aftermath after the breach. So it's not a pleasant thing to have it. And then they published that the root cause was Apache Struts that they were using. And we anticipate that within the next 2 to 3 months, there's going to be thousands of organizations that still use the vulnerable version of Apache Struts. It takes a lot of time for organizations to actually understand that they use Apache Struts and apply the fixes. So let's talk about shifting left and why you should shift left your open source security. So shifting left is about detecting and fixing issues as early as possible in the process. You don't want to discover such issues in production. And as we said, with open source, you can understand the components you're using already when you're developing and when you're building your software. And you can do it continuously. So you don't have to go into production with vulnerable components. The traditional model that works for proprietary code needs to be changed and actually shift left to support the capabilities of the open source community and the fact that you can actually affect things earlier in the process. What you should basically do is you should integrate open source management into your continuous integration processes. So the company I work for, WhiteSource, is a startup company that was founded 6 years ago. And we provide open source management solutions. We work in a software as a service model. We basically help you block the usage of vulnerable components in your products, detect them early and fix early in the process. And we also give you remediation advices on how to fix the issues, either by applying patches or by changing the code that caused the open source components. But this is being done early in the process and with every build. So you can fix it before it goes live to production. We have more than 3 million open source components that we monitor, and about 70 million source files and tens of thousands of known vulnerabilities that we know of. And we have a 24/7 system and a research team that tracks all these public databases for new vulnerabilities, and we send alerts to our users whenever a new vulnerability that affects them is actually published. So to do that shifting left, we actually partnered with Microsoft. And we do that in 2 ways. One is our software as a service solution runs on Azure. You can get it on the Microsoft AppSource website. Basically, just search for WhiteSource software on the Azure AppSource website. The solution integrates with more than 30 build tools, build servers, and repositories like GitHub and others. Most importantly is Microsoft TFS. But we've also developed a special integration for Microsoft Visual Studio Team Services called Bolt. So Bolt basically integrates into your native CI/CD pipeline, and it allows you to automatically detect vulnerable components and dependencies to fix them early in the process, shifting left. It also generates an inventory of all the open source components you're using together with their dependencies, generating a bill of material for every version that is being built. And it ensures license compliance, so every open source component being used is being matched against the company's policy to see that it's actually compliant with what the company has determined as allowed. So key takeaways, open source is not your proprietary code. You need to think differently. You need to find and fix issues early in the process. You can't do that manually because these databases are not searchable. And even if they're searchable, they're not searchable by the components you're using. And the components you're using use other open source components, so it's really, really hard to track it manually. You need an automated tool in place. Response time is critical because hacks on open source components are available to everyone, so you really have to be on top of it and fix vulnerabilities early. There's no remediation information in these databases usually, except for sometimes, just apply the new version, but you need more than that to be actually safe. But there's also some good news. First of all is that the community also contributes and releases fixes. As we said, 87% of vulnerabilities are also being fixed by the community. It's easier to detect open source vulnerable components because it's public. You don't have to run proprietary code scanning tools that are based on rules and heuristics. And it's also easy to fix them because most probably someone else already fixed the issue. Thank you.